तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करने वाले हैं. A coil of inductance 2 Henry having negligible resistance is connected to a source of supply whose voltage is given by V is equal to 3t volt. If the voltage is applied when t equal to 0 seconds, then energy stored in the coil after 4 seconds is. So what we have to find out is how much energy is stored in the coil whose inductance is 2 Henry and the voltage applied is 3t volt. So you can see that the voltage is given by this particular function. If you want to find the energy stored in the coil, we have got a simple formula to do that. So energy stored in the coil is equals to 1 half Li square. Okay, this is the formula. Now L is the inductance. So inductance is given as 2H. As you can see over here, it is given as 2H. So if you know the current, then we can easily find the energy, right? So how to find the current? What they have given is they have given the voltage and it is a function of a time. So V is equal to 3t. That is what they have given. We also know that voltage is equal to L di by dt. Okay. So you should know this particular formula. Voltage is equal to L, which is inductance, and di by dt. But since voltage is equal to 3t, we can write is equal to 3t, which translates to L di is equal to 3t dt. Okay. So if you want to find the current, what we can do is we can do the integration of both sides. So L integrate this one. So initially current is 0 to I is equal to 3 t equal to 0 to t and t dt. So if you do the integration of this thing, what happens is that Li 3 t square half. But we know L is 2, okay? So we can write I is equal to 3t square divided by 4. And what we have to do is that we have to find the energy stored after 4 seconds. So if you put the t's value as 4 over there, current will be 4 divided by 4. So current will be 12 ampere. Okay. Now we know that the energy is given by this formula. So we can write 1 half into 2, L is 2, and current was 12 ampere. So 12 into 12. So 2 is cancelled out, and then energy is equal to 144 joule. That's it. That's how you can find out this energy stored in the coil. So just to repeat what we did, what we were given is the coil of inductance of 2 Henry. So H is basically Henry, which is the unit for the inductance. And here they have given the voltage in this format 3T. So what you need to know is that these two formulas you need to know. Energy is given by this formula in the induction coil, 1 half Li square. And other formula that you need to know is voltage is equal to L into di by dt. Okay. So after that, what we did is that voltage is given, so we just put it over here, and then we moved the dt over there on the right hand side. So what this formula tells us is that for a small fraction of time, how much current is being flown in that particular coil. But what we want to do is that we want to find the total current flown in the 4 seconds. And that's why we need to take the integration. Okay. So we want to find the total current. That's why we have done the integration over here. And after the integration, what we have got is this particular formula for the current. I is equal to 3t square divided by 4. And once we know the current, then it is very simple. We have to just use this formula. Energy is equal to 1 half Li square. That's it. Thanks for watching.